Okay, so this is just some extra exact value practice, which you're going to be responsible for like a no calculator portion of the test, right? So this sheet here that I would have handed out is just an extra, it's from the actual teacher copy of the Nelson textbook. It's just some extra practice around exact values. Okay, and so this is just a recap of those special triangles, and we'll use these quite frequently throughout these videos, I suppose, on this particular sheet. So I think in order to do this, what we'll do here, we'll just redraw these triangles. Okay, and if you need supplementary videos on how we came to get these, you can watch one of the lessons that are on the website. It's 4.3 if I'm not mistaken. So what we're doing is building angles using these, I guess, it's really just two triangles that we can orientate differently. So that's going to be your 60-degree triangle, and then your 30-degree triangle. And you'll see in a minute when I go through the video for number 2, you're going to see that we're going to end up using these to evaluate as well. Okay, so this is going to be the angle 30, 60. Okay, so we have the 45-degree triangle, we have the 60-degree triangle, and we have the 30-degree triangle. Okay, and what this is asking for 1A, 1A is just simply asking us for the cosine of 60 degrees. Okay, and the cosine of 60 degrees, that means I'm going to look at this triangle here in the middle, and I'm just going to write the trig ratio that corresponds with the cosine, right? And that's going to be adjacent over hypotenuse, right? So if I'm looking at that 60-degree triangle, I'm going to write down the side lengths that correspond with adjacent and hypotenuse. And in this case, the cosine of 60 is going to equal 1/2. Okay, if I do question B, the tangent, okay, and recall too, I'll maybe just write this, we're dealing with SOHCAHTOA because these are 90-degree triangles. Okay, and so if I'm looking at the tangent of 30, I know the tangent of 30 is going to be opposite over adjacent. And if I'm looking at the 30-degree triangle specifically, that's the one over on the right, then I'm just going to write down the tangent or the ratio opposite over adjacent of that 30-degree triangle. And so what I get here is that the tan of 30 is going to equal 1/√3. Now, when we have questions like this, we have one slight complication, and it is that I typically don't leave a radical in the denominator. So what we do is we rationalize it by multiplying by √3/3. And so I see that the tan of 30 is going to equal √3 by, I'll just do this so that everybody can see. When I multiply two radicals together, it's like x times x. It becomes √9, right? Which I know to become, this is why this worked, √3/3 would be the final answer for that one. Okay, C. C is asking me for the sine of 45 degrees. So I just jump over to the 45-degree triangle, and I write out the trig ratio that corresponds with sine, which is opposite over hypotenuse, right? So I write 1/√2, which again I need to rationalize, and I get √2/2. And then I have one more, and that's a tan of 60. Okay, the tangent of 60 is going to be, again, I'm looking at the 60-degree triangle in the middle. That's going to be √3/1 when it's opposite over adjacent. Okay, so a nice little video there just to recap how to come up with those trig ratios, the exact values. And then what we're going to do, if you can do that, we're just going to start evaluating in expressions, right? So multiplying some of these trig ratios together and ultimately landing on an answer at the end, okay? So that's it for number 1.